Hello. We're just doing a really basic setup of IP version 6 just to get IP6 up and running on a router. Have a look at our PCs and servers and whatnot and just make sure that we've got connectivity. I'm actually using a packet tracer that I've already used for RIP, but when I did RIP with IP version 6 or RIP-NG, I figured that I hadn't actually gone through the basic configs of it all, so I thought, well, let's go back and do that. So here we are. Okay, so this side is all configured. I've undone some configuration in this nice, I don't know what, it's like a sick color, isn't it? Sick green. I kind of like it, but anyway. So what are we doing with our network? So I want to get router 1 talking to these PCs down here using IP version 6 and getting them chatting away with that protocol. So I can put in a static address on my PC. So on my server here, I've got this network number. It's a 64-bit subnet mask. You can subnet IPv6 further if you choose to, but why? I don't know. Effectively what we're given, when we talk about subnetting IPv6, actually just to go into it, this first 48 bits that we get, and I've actually highlighted 48 bits there, because each of these values is 4, so there's 4 bits actually, sorry. So 16, 32, 48, there should be 2 double zeros in front of that, but because we've shortened it, so each value here, that is 4 bits in hexadecimal, that's another 4 bits. So the first 48 bits, at least, is given to us by our ISP. Now they do change it sometimes. Sometimes you get 56 bits, particularly for your home networks, but for larger organizations, 48 bits is what your ISP is going to give you. Then in this fourth quartet, or whatever it is called, portion of our IP6 address range, we're putting in a different network number. So this is what is called subnetting in IP version 6. So you can see that we've got the same prefix, so 2001 C0FF is our same prefix. The 48 bits is the same there, same up there, and all we've done is added a different value into this fourth quartet thing. So 1 there, 2 there, 3 there. They just need to be different numbers. And that delineates our different networks, and they all end up being /64, and we're all good. I'll come back to this one in a minute, although it's probably worthwhile putting it in there now. FE80, this is our link local address space. So FE80 :1, these addresses will stay internal to our network. So you can see a lot of FE80 :1s across our network. On router 3 over here, actually let's go to the static over here, desktop. That also has an FE80 :1. That link local address does not get outside of this network. In fact, this router can have FE80 on 3 different interfaces there, if it wants it, because each belongs to its own network. IPv6 does not have broadcasts anymore, like IP4 sends broadcasts all over the place. The FE80 is used a bit more often. There is other things that go on where it's just sending stuff out, and it's mostly multicast addresses, but that's okay. So back into this router. So this is our gateway, so that's the address that we expect to be on our router. And a lot of our talk will actually happen on these link local addresses. In fact, when you do RIP on this, we don't have network addresses between the routers. I've just used FE80, and the routers will update everything through that. This little address has been acquired. So we've got a prefix of FE80, which under the standard is the first 12 bits need to be FE8. Everything else beyond that remains to be seen. Now this is an interesting one because this is an EUI64 address. It's been automatically created by using the MAC address of this interface and injecting into the middle of that MAC address FFFE. Now there's one other thing that's happened, is the 7th bit of the MAC address has been inverted as well. So an EUI64 will inject into the middle of your MAC address FFFE. That makes it from a 48-bit address to now a 64-bit address, and it'll also invert the 7th bit. Now the 7th bit, if memory serves, originally it was used to say it is a physical interface. If it was a 0, you'll have to double check that one. If it was a 1, it was a virtual interface. So yeah, it inverts it. Now Microsoft doesn't use the EUI64 because if you're pretty much giving away the MAC address of your device for a globally routable IP address, because IPv6 should be able to go across the internet. There's enough address space now that you don't have to hide behind NAT or proxy. You should be able to connect directly to the internet, run your own firewalls on your local PC or run a transparent firewall, but you end up with your address actually having the MAC address on it. So hackers can use that. Anyway, I've got a static address there, 64. There's our EUI64 in there, and our link local address is our IPv6 gateway. Now, on our other PC, I've got autoconfig running. I don't have an address acquired. I've got no gateway. It has obtained its local FE80 or link local address. So we need to get this up and running. We're not going to use DHCP. We're actually going to use this one, which is SLAAC, SLAAC, which is stateless address auto configuration. So SLAAC is the address we want to get given from this PC to this router. So let's get that up and running. So let's go onto our router and actually put an address on the interface. So I've just ripped out a bunch of stuff, so let's clean that up. And we'll go into conft. We'll go into our interface gigabit 00, and we're going to put an IPv6 address onto our router. So we need to have a link local address applied, and we need to have an IPv6 address applied. So let's go for the link local first. So FE80 :1, and then we actually have to say this is link local address. So one address applied, and we can apply other addresses to this interface. Normally in IP4 you can't do multiple addresses. So part of this network, so we've got to get the right network number. C0FF EE1 is my network number, and then all zeros and a 1 will be this address for this network. Now we put in a /64 because I'm not going to type out a whole bunch of F's for that subnet mask. And that's it for the interface. Let's just make sure it's up and running. So show IPv6 interface brief, and let's move it across a bit. So our serials have FE80 on them. Our gigabit 00 has FE80 :1, and then 2001 COFE11 hasn't given us our subnet masks, and it's up and up. So it's a slightly different look to show IP interface brief for IP4, and that's good. Now, this PC still hasn't acquired the Slack SLAAC. What it should be doing is sending off an RA, and RCs, other things like that. So let's have a look. Let's rejig it, see if it actually pops up. So Network Discovery Protocol is going to run, and it's not a broadcast, go figure. So it's going across and trying to find different information for us. So let's pop back, one is viable. In here, under IPv6, we're trying to find the gateway for our network, because we're not actually looking for a DHCP service, and it is using particular address. Destination IP is FF02:2. The source is FE80, and that's our address there. And it's saying, look, I need to get some information. It's not a broadcaster, and it's not working. So why isn't it working? We've got the correct information on our interface. If we show run, we have a look at our interface. We've got our link local address, we've got our IPv6 address, that's all good. The thing we're actually missing is we haven't enabled IPv6 on the router. Even though we can apply these addresses, we still need to type in this command, IPv6 unicast routing. And that says, okay, you can run routing protocols, you can run Slack off this device. Keep doing that, and everything should work out. So let's see if it goes. Boom, straight in. So this machine down here has now acquired this address. So 2001 COFE or C0, it's a 0, it's not an O, and that's our prefix, so /64, and we're using an EUI64 as well, so the same IP address, if you like, or the host number is in our IP address, IPv6 address, as in our link local address. And there's our gateway, FE80:1. So that's it. That's pretty much all we need to do to configure IPv6 on a router and on a PC. So in the PC we can either type it in physically, or we can use Slack to actually obtain, so this auto configuration option to contain everything. We'll have another video about DHCP with IPv6. There are extra things we can do on our router to actually give ourselves a DNS server, but if you think of it, what we have is just about all we need. We've got an IP address, we've got our gateway. From most networks, the thing we're missing is the DNS services. So we can put that on the router, not running it as DHCP, but we'll do DHCP and everything else in another video. So that's it, basic config for us to get going, to at least get our routing and everything running on our network. Thanks for listening. Cheers.